Hello everyone, this is Joseph. Welcome to today's video on highest common factor HCF and lowest common multiple LCM using prime factorization. Let's do a quick recap. Now in primary school, P4 math, we also learned about factors and multiples. In primary school and secondary school, both use the same term, common factors. However, in primary school, the greatest common factor is used to represent the number that is the largest integer in the list. But in secondary school, we call this highest common factor. So greatest common factor in primary school should be the same meaning, or rather is the same meaning as highest common factor HCF. Common multiples is the same term used in primary school and secondary school. In primary school, we have the first common multiple in the list. Okay, then in secondary school, this term is now known as lowest common multiple LCM. So it's just to explain to you that the two primary and secondary levels, they are using the same concept, but the naming system just changed a little bit. Now, today I'm going to share with you how to go about using prime factorization to find the HCF and LCM of 90 and 140. Okay, so let's do a quick recap how to find 90 and 140 using repeated division. Okay, so let's do 90 first. Okay, so for 90, remember we do this way. All right, the inverted division sign, and we are always using prime factors, okay, or prime numbers, sorry. So prime numbers are 2, 3, 5, 7, 11, just to name a few. Okay, let's always start with the first, the smallest prime number, which is a 2. Okay, so I'm going to start with a 2. So 90 divided by 2 gives us 45. Okay, now that means we can proceed. So the next division, so that's why it's called repeated division, but it's the inverted division symbol. Now, 45 can no longer be divided by 2 because it gives us a remainder. So we move on to a 3, the next prime number. So 45 divided by 3 gives us 15. Okay, all right. Now, 15 can still be divided by 3, so we proceed to use the prime number 3. 15 divided by 3 gives us a 5. Okay, now 5 can no longer be divided by 3, so we move on to the next prime number, which is a 5. So 5 divided by 5 is a 1. Okay, so we stop our repeated division once we arrived at the number 1. Okay, so that means from here, we have already gotten the list of factors, okay, for 90. Okay, so I'm going to write down later. Next, I'm going to move on to 140 using the repeated division. Okay, 140 is an even number, so I can try 2. All right, so 140 divided by 2 gives me a 70. 70 is still an even number, so I can proceed divide by 2. I get 35. Now, 35 is an odd number. It can no longer be divided by the smallest prime number 2. So we move on to 3. But if you have noticed, 35 is not divisible by 3 because 35 is not a multiple of 3. So, sorry, we skip the prime number 3. So we move on to number 5. Yes, 35 can be divided by 5, gives us a 7. 7 can no longer be divided by prime number 5. So we move on to the next prime number, which is a 7 itself. Okay, can. And we arrive at 1. Okay, good. Once we arrive at 1, we can stop our repeated division. Okay, I'm going to write down the factors of 90, okay, using index notation. So 90 is actually 2 times 3 times 3 times 5, which is written as 2 times 3. 3 appear twice, so 3 to the power of 2 times 5. Okay, now next we have 140. Same style. 2 appear twice, right? So 2 to the power of 2. 5 appear one time. 7 appear once. Okay, so I've already written the factors of 90 and the factors of 140 using index notation. Now, from here, I can already look for the highest common factor of the two. So the HCF of 90 and 140 should be what? Okay, so we compare these two lists. Okay, these two lists. Okay, now it has a 2 here, 1, 2. So, and 140 has 2 of them, right? So it's okay, we take 1 only. Okay, now 140 cannot be divided by a 3 because there's no 3 in the list here. So we move on to the next one is 5. So 5 is common. Okay, so the common multiple of 90 and 140 is 10. 2 times 5, 10. So this is common. This is common. Okay, right? I hope I'm not confusing you. Okay, now do play back this video if you are a little bit confused. Okay, right now I'm going to move on to LCM. Okay, now for LCM, we are supposed to place both side by side with a comma when we use repeated division. Put them side by side again using our prime numbers. Okay, let's try 2. Okay, so that gives us 45. That gives us 70. Now, we still need to try 2 because for 70 is an even number. Okay, but nothing can be done to 45. So 45 cannot be divided by 2, right? So we bring it down. But 70 can be divided by 2, so that gives us 35. Okay? Okay, now 2 is impossible for both. Alright? So we move on to the next prime number, that is 3. Yes, 3 is a divisor of 45, that gives us 15. But 35 cannot be divided by 3. So if it cannot be done, we copy down. Okay? Alright? So this part copy down. This part copy down. Okay? Alright, move on. Okay. Now, any more 3? Yes, we can. 15 divided by 3 is 5. 35 cannot divide by 3 again, so copy down. Okay? Alright, I have no more space, so I'm going to do it here. Okay, repeated division continues. Okay, I think 3 cannot be done anymore. Let's move on to the next prime number, that is a 5. So 5 divided by 5 is 1. 35 divided by 5 is a 7. Okay? Okay, good. We got a 1 there already. So our repeated division for number 90 is done. It ends here. But we have to move on. We have to continue because of 7. Okay, so 7. Right? So 1 is ends, right? Okay, so we just copy down. but 7 is the last one. And it ends for the 140. So from here, we can see that all these are the numbers that we need to use when we write the index notation for the LCM of 90 and 140. So let's write down this in index notation. So let me write down properly. So LCM is equals to, now 2 appear how many times? Twice, right? Okay, so 2 to the power of 2 times 3 appear twice also. So 3 to the power of 2 times 5 appear only once, so 5. And 7 appear only once, so times 7. Okay, so the LCM of 90 and 140 is 2 square times 3 square times 5 times 7. So if the answer is, if the teacher is asking you for LCM of 90 and 140 written in index notation, we are done. But if they ask you for the actual value, you have to work it out. You have to use your you have to count, you have to physically multiply all this out. Meaning 2 times 2 to the power of 2 is a 4, 3 to the power of 2 is a 9, 2 to the power of 2 means 2 times 2, that gives us a 4, 3 to the power of 2 means 3 square means 3 times 3, that's 9, then you times 5 times 7. Okay, so your job is to multiply all this out. You'll know that the number is very huge, and that is the LCM of 90 and 140. But if the teacher is asking you for the index notation representation, okay, then this is already good enough. Right? This is the index notation. Okay? Right? Remember, if it's a little bit confused, play back the video. Okay, I'm going to move to a GCE O Level question. It is taken from the year 2010. It is a paper 1 question and it's number 10. Okay, the question goes like this. Written as the product of its prime factors, 4,900 is equal to 2 square times 5 square times 7 square. That means 4,900 is equal to 2 to the power of 2 times 5 to the power of 2 times 7 to the power of 2, written in index notation. Now, they are asking us to do express 168 as the product of its prime numbers. Okay, so I believe we have to use index notation the same way. That's for part A. Then for part B, right? After that, hence write down the LCM of 4,900 and 168, giving our answer as a product of its prime factors. Then B part 2, continuation, find and write down the greatest integer that will divide both 4,900 and 168 exactly. Okay, I'm going to show you this, how to go about doing this question, GCE O Level 2010, paper 1, question 10, in a very slow way. So you follow me, okay? All right, next slide. Okay, let's do part A first. Now, part A is asking us to express 168 as a product of its prime factors. Okay, now remember, writing 168 as a prime factor, we have to do something called prime factorization, okay, using repeated division. Okay, so we are very familiar with this, so I'm going to do it now. 168 repeated division, we introduce the smallest prime number, which is a 2. So 168 divided by 2 gives us 84. Now 84 can still be proceeded. Divide by 2 again, I get 42. 42 is still a prime number. Sorry, 42 is, I beg your pardon, 42 is an even number, so we can still proceed to get 21. 21 is an odd, so we cannot use prime number 2 anymore. We have to move on to the next prime number, which is a 3. So 21 divided by 3, yes, 7. Okay, now 7 divided by 3, no, cannot be done. The next prime number is 5. 7 cannot be divided by 5. So we move on to the next higher prime number, which is a 7 itself. Can. Okay, we stop at 1. Congratulations. So 168 written as its product will be 2 appear twice. So 2 appear 3 times. Then you have times 3, you have times 7. Okay, so writing in index notation, 2 to the power of 3 because it appears 3 times. Then times 3 times 7. Okay, I have completed part A. Okay, I've completed part A. All right, so let me write down here for you. This is part A. Part A is done. Okay, I'm going to move on to part B. We are supposed to find the LCM of 4,900 and 168. Okay, we use back part A answer. Okay, all right, so I'm going to rewrite that expression here. This one. Okay, I'm going to write down here. 4,900 is written as 2 to the power of 2 times 5 to the power of 2 times 7 to the power of 2. Okay, to find the LCM, okay, let me change the color. To find the LCM of 168 and 4,900, what we need to do, we have to compare these two lists. Compare these two lists. Okay, all right, compare these two lists. Okay, now 168 has 2 appearing 3 times, but 4,900 has only 2 appearing twice. So the LCM, the one that is common, is 2 appearing twice only. Okay, so all right, we have to follow the one that is common. Okay, now let me write down a bit clearer for you. Okay, I'm going to split up this for you to see. This is 2 to the power of 3. This is 5 to the power of, no, wrong. 2 is to the power of 2 only. So 2 to the power of 2, 5 to the power of 2, and 7 to the power of 2. Okay, what is common between the two number? Okay, I'm going to circle for you. I'm going to do LCM here. So 1, 2, common. Okay, then that's all. Then after that, 7 is common. Okay. All right. Okay. Now remember, LCM is multiples. So we still need to use back the original. We still need to use back the all. Okay, so 2. Okay, we have to follow the one with the greatest power. So LCM 2 must be 3 times. Okay, the greatest power. All right, even though here you only have 2, we have to follow this one. We have to follow this because of multiple is right. It must be common for both. Right. Okay. Then what happened is, let's look at 5. Let's look at 5. 168 has no 5, right? But 4,900 has 5. So no choice. We have to follow this. Okay. All right. Now, okay, my apology. I skipped a number. We always write down in increasing order. So we cannot ignore the 3. Okay, so 3 must be that. 3 appear only one time. Okay, then 5 appear twice. You have to look at both. Look at both. Look at these two sets. Okay, right? Whatever you can see there, you have to copy down. Okay, so let me check again. 2 cube comes from 168. 3 comes from 168. 5 square comes from 4,900. Okay, and we are left with a 7. Okay, so 7. The one that has the biggest value is this one. So 7 squared. Okay, so the LCM of 168 and 4,900 is 2 to the power of 3 times 3 times 5 to the power of 2 times 7 to the power of 2. Okay, all right, we have completed part 1. We have completed B part 1. Done. Okay, remember LCM means it must be inclusive. It must include all the factors in the two numbers 168 and 4,900, the maximum. Okay, all right. Okay, now next I'm going to do the B part 2, which is asking for the greatest integer in the next slide. Now, greatest integer here, right, means it must be a whole number, right? We will know more about integer later, okay? The later part of our chapters. Now, and it has to be that can divide these two. That means it is a divisor for both 4,900 and 168. All right. From here, you already know the question is asking us for HCF. See, the word greatest tell you is the highest. Okay, so a factor is a divisor that can be used to divide the numbers. So part 2, B part 2 is indirectly asking us to find HCF. Okay, all right, okay. So let me write down the two numbers in their prime factors first, okay? Okay, then we can explain clearly from here. So 168, this one was used earlier. Let me change the color. Okay, 168 in our earlier slides is our 2 to the power of 3, and then 3 to the power of 1, and 7 to the power of 1. Okay, then 4,900 taken from here is 2 to the power of 2. Okay, they have no 3, it has a 5, and it has 7 to the power of 2. Now, for HCF, we only pick up those that is common. Okay, so I'm going to do it very slowly. Yeah. Okay, so common, no more 2s, no more 3s, no more 5s, 7, yes, common. Okay, so HCF of 4,900 and 168 is 2 to the power of 2, because, okay, let me write down nicely. So 2 times 2 times 7. So we write down the common circled numbers. Okay, this can be written as index notation 2 to the power of 2 times 7. Now 2 to the power of 2 times 7 is simply 4 times 7, that gives us 28. So the highest common factor of 4,900 and 168 is actually 28, and 28 is the greatest integer. 28 is the greatest factor, common factor, that can divide both 4,900 and 168 exactly, leaving behind no remainder. So this is the answer for B part 2. Okay, we have completed the discussion on HCF and LCM using prime factorization, citing an example from GCE O Level 2010. Now, in my coming videos, I will be sharing with you square roots and cube roots using prime factorization, a very important concept. Okay? Now, if you like my today's video, give me a thumbs up, give this video a thumbs up, like the video. Feel free to drop me some comments, feedback, motivation, suggestion. Okay? And don't forget to share. Okay? Share with friends who want to know more about this, who are embarking on secondary school math. And I strongly encourage all of you to subscribe. When you subscribe, you get to be notified of my future videos being loaded. Okay? Uploaded. All right. So I hope you can understand today's discussion on HCF and LCM using prime factorization. Remember, do feel free to always watch again and again. Okay, all right. See you again. This is Joseph. Goodbye.